Question 55 says, what is the period of the function f of x is equal to the cosecant of 4x? As answer choices, we have a bunch of expressions involving pi. And another thing that stands out is that these seem to be kind of opposite pairs here. So C and D are opposites in the way, in a sense that in C we're multiplying by pi by 4, and then in D we're dividing pi by 4. And same thing with B over here. We're multiplying versus dividing by 2. And another kind of pattern here is that it seems like they're doubles between A and B, between B and C, and between D and E. So we see that there are a lot of opportunities to make some small mistakes and mix things up. So we'll want to be especially careful of those while we're doing this question. As far as the math concepts in this question, we are dealing with a period, and we're also dealing with this trig function. And essentially what they're getting at here in a formal math sense is they're testing our understanding of the transformations of trig functions. And if you're familiar with all those transformations, then this question will be pretty straightforward. And we'll go over that formal way of solving this question a little bit later. There is another way of solving this question, though, which depends entirely on understanding the definition of period, as well as being familiar with how the cosecant is defined. And if you know those two things, even if you're sort of rusty or you haven't learned about transformations of trig functions before, you can still get this question right. And this question turns out to be a great demonstration of how, if you have a solid understanding of the essential concepts like period and things like that on this test, that they've designed the questions in such a way that you can be resourceful and still figure out the answer without having to know all this super advanced math knowledge. So I'm going to write out at the top here the two different approaches that we can take. So the first approach is, approaches 1. We'll do it in a more concrete way, which is rely on, let's just say we're just going to graph this. And then the other one is the more formal way, which is use knowledge of trig transformations. Before we go into either of these two solutions, as I mentioned, we do need to have an understanding of the terms here. I'm going to start out by writing kind of an informal definition of period. And this is really all we need to know when it comes to a question like this. A period is essentially the distance between repetition points on a sort of cyclical graph. So for example, if you have a sine curve or a trig function, it's going to just cycle, and the distance between any 2 points that repeat is going to be the period. And this should be the shortest distance. Just clarify that. And then the other thing that we need to be familiar with for this question is the cosecant, the definition of cosecant. And the way cosecant is defined, cosecant is essentially the reciprocal of the sine function. And we know that sine, or we should know that sine is opposite divided by hypotenuse. And so the cosecant is going to be the hypotenuse divided by the opposite side. Now, with these two definitions in mind, we are in a great position to solve this question. The next step is to realize that since a period is just this distance, the short distance between repetition points on a graph, we can actually just graph this function and visually count what the period is. I'm going to take out the calculator here, and let's see here. We're going to go to y equals in order to graph this. Then the other thing that we need to know in order to graph this is how to input cosecant into our calculator, because the TI-84 at least does not have a cosecant button. So we're going to now use this understanding that the cosecant is the reciprocal of the sine function in order to input this into our calculator. If it's the reciprocal, that means that it's the same as 1 divided by the sine. And we can now put in the 4x here to complete this. And the other thing that we're going to want to do at this point is check what mode we're in. These answers are in terms of radians, so we'll want to make sure we're in radian mode. Usually we're going to want to be in degree for the ACT, but occasionally we have to switch back and forth. So the mode, I'm already in radian mode, so we're good there. And to graph a trig function, usually I'll start out by going to zoom and then z-trig, because it formats the picture to be for trig functions specifically. And what we see here is this kind of strange looking graph, but it is cyclical like we would expect. And we're going to now use our understanding of period, which is just going to be the shortest distance between repetition points. And we see a bunch of repetition points here. For example, if you look right here, this point gets repeated over here and over here. So that distance is going to be our period. So if we can find that, then we're going to be done with this question. What I would try to do here is just choose 2 points that are going to be easy to kind of measure. So for example, this point right here is right about at the origin, and we see that it repeats right over here, which is right at that tick mark. So if we can just find the sort of value of that tick mark, we know the period. So I'm going to just move the cursor over. So we're starting here at 0, and then we'll pay attention to this x value to see how much we're going to need to go over to get to that next repetition point. And it looks like 1.57. Now, in terms of radians, which our answer choices are in terms of, this is going to be the same as pi over 2 radians. And if you want to check that, you can just go to the calculator here and put, pi divided by 2, and we get 1.57, which is that same value. So our answer to this, what is the period of this thing, is going to be pi over 2. Now that we have done it in the concrete way, let's review the more formal way of doing this. The formal way of doing this relies on this understanding of trig transformations. And the first thing we would need to know for that is the period of the regular cosecant function. So by regular, I just mean just cosecant of x without any transformation applied to that. And by transformation, I mean right here we have this number 4, which is going to affect how that graph looks. The cosecant of x is going to have the same period as sine of x, since they're just reciprocals of one another. So the period of this is going to be 2 pi, which is another thing that we would need to know. Now from here, we would use the fact that if there's a number, a constant, in front of the x on a trig function, what that's going to do to the period is it's going to divide the period by that particular number. So since the standard period without any transformation is 2 pi, we're going to divide the 2 pi by 4, and that's going to give us our new period. So 2 divided by 4 is going to reduce to just pi over 2. And that's the same answer that we got by looking at it on our calculator. Now, I'm purposely not going into too much depth here about trig transformations. I'll link to some resources that explain it in more detail, but it's sort of beyond the purpose of this video to go into all that, as I mainly want to show just the different ways we could solve it. If you already know trig transformations, then you're already set. And if not, then we saw that there is this other way of approaching the question. Let's take a look at the wrong answers, which might make more sense now that we've talked about the formal way of doing it. Answer choice B, for example, could reflect just getting the standard period of cosecant without any transformation, because we had said that that was 2 pi. Answer choices C and D, which both have the 4 in them, could reflect the mistake of thinking that the period of cosecant is actually pi instead of 2 pi. Because if it were to be pi, then we would divide by 4 over here to get our new period, and that would be answer choice D. And then C could reflect mistakenly thinking that it's pi, but then instead of dividing by 4, multiplying by 4. And then A could reflect just sort of like B was the standard period of cosecant. It could reflect mistakenly thinking that pi is the standard period of cosecant as well. Let's think about what we ultimately needed to know for this question. As we saw, if we understand trig transformations and we remember all this stuff about the standard period and all that, then we're definitely in good shape. We can solve the question very quickly. That being said, one of the really interesting things about the way this question was designed is that if we have a really solid understanding, actually even just sort of a basic understanding of the word period, and we understand that the cosecant is the reciprocal of sine, and it occurs to us to graph it, then we can still get the question right without any transformation knowledge. And that's a theme among a lot of ACT math questions, which is that if you have a solid conceptual understanding of the foundations, they designed the questions in a way that you can still navigate through them and get them right. And that's a really key takeaway, because a lot of times students who are just starting out will look at a question that kind of looks like this, and they might even know what a cosecant is and also a period, but they forgot or never studied transformations before, and they'll just automatically assume that they don't know enough to get the question right. So it can be helpful in those situations to remember that the ACT often rewards a deeper conceptual understanding of ideas, as well as sort of a resourceful, flexible problem-solving spirit, as opposed to memorizing a bunch of formulas and things like that. And the last thing is, if you'd like to see more examples of questions that can be graphed and solved through graphing, you can also check out question number 4, 44, 54, and 59 from this test, because those all can be solved using a similar approach as we took on this question. That about wraps things up for this one, so let's go on to question 56.